Hello everyone, welcome to Civil Mania. So in today's lecture I'll be telling about how to do the design of a multi-story building. If I'll be applying the wind load, live load, earthquake load and dead load as well. So all the loads I will apply here, and I'll be doing the analysis and design of the multi-story building using Risa 3D. So let me open the software first. So I'll be first clicking the create new file. After clicking on the create new file, this is how our new model will start. As you can see here, you can input your company name, design name, model name, and all these things you can input here. After that, click on OK. After clicking on OK, first you need to go to the units. After going to the units, you need to set the what kind of units, whether you want empirical units or the metric units. After setting the all the units, as I will do the numerical in the metric unit, so I will be setting all the units in the metric unit. After that, click OK. Then you need to go directly to the view tab. Then you have to turn off the project grids. Along with that, you need to go to the drawing tab and turn off the display grids. After that, there is the no requirement of display grids, because display grids is required when you need to do the drawing manually. Like simply you can go to these settings, and after that in this settings you can like set, as there are 30 increments of 0.30, I can set as there are 30 increments of 1, and in the x-axis, in the y coordinate also I can set the 30 increments of 1. So this is how we need to set. So this is what the grid system. So here each unit is 30 in x and y coordinate. So this is required when you need to do the drawing manually by the help of grid display. So but here I am simply turning it off the grid display, because there is the no requirement of grid display here. After that, you will go to the home button. There you can see the templates present. Click in the templates and click in the 3D grid. After clicking in the 3D grid, as you can see here, this is the as you can see here. So this is a one kind of 3D figure, and here I will select the polar origin as the 0, 0, 0, and it's selected by default. But remember that I will create the plates only in the roofs, whereas in the walls I will be creating the wall panels. So the roof is the XZ plane, so I will uncheck all this. So plates will be created only in the like roof portions, as well as the bottom portion, that is the slab and slabs. Here I will select the concrete thickness of the roof. I will provide as 120 mm. Okay, there is the no requirement of fluid load. Okay, click next. After that, in the x-axis I will be providing the two increment. One is of 5 meter, one is of 6 meter. Then I will be selecting here the concrete material. After that, I will be selecting here the section set. Let me select here the section set, create new section set. I will write here the section set. Okay, let me cancel it because one section set is already present. First let me edit that section set. Here I will write as, in the x-axis we will be creating the beams because columns are present only in the y-axis. So width of the beams provide as 400 by 350. Okay, as I have already edited this one. Okay, beam x 400 by 350 edited, beam rectangular, keep it as M20. You can also go to the edit and you can set other values such as minimum depth, maximum depth, then maximum bending check, deflections value. All this you can set manually for the beam. Even you can set how much amount of rebar is required, like minimum, like flexible bars, maximum bars. These are actually the diameter of the bar. Minimum is 10 mm, maximum is 18 mm, shear bars is of 6 mm. You can also provide shear bars of 8 mm. So this is how we can like set the values manually. And 2-leg stirrups you can keep as 4-leg stirrups. Top cover, bottom cover, everything is okay. Click on OK. After that click on OK. Now the section set name will be beam X. This, as you can see here, beam X. Now go to the next, and after that you need to set in the z-axis. Here also I will keep 3 panels. Suppose here I will keep as only 2 panels, that is one is of 5 meter, one is of again 6 meter, such as I have kept in the x-axis. Here I will keep the section set as, go to the concrete section, beam X I have already set. Let me create another one. Here I will keep as beam Y concrete 400 by 350, dimension beam rectangular M20. I will here again edit it and make the shear reinforcements, minimum diameter as shear bars 8 mm. Everything is okay here. So this is what the z-axis. Now in the I'll again click next. In the next again I'll keep for wood. After keeping wood here I will here I will keep as concrete. Then again I'll create here as the beam section as the because in the y direction there will be no beam, but there will be the columns, so I have kept as columns. After that I will edit their dimensions as 400 mm by 400 mm. Then here you need to change it to columns, rectangular M20. Edit it here, make it as everything is okay here. Okay, so but remember that here I have kept the increment as, if I need to create a building of 10 story, then 3 3 3. So I have kept 10 increment here. It means it will be a 10 story building. Click on OK. Just wait for a moment, the model will get created. This is what the model got created. Now close it. So as you can see here, the model got created. Now what you need to do is, now you need to go to the modify tab, click on delete single, then delete these members. You need to delete these members. Or let me go to the isometric view. As you can see here in the isometric view, you have to delete these members as well as this. You have to delete these members as well as you need to delete these plates. After deleting these plates, delete these beams, because there is no requirement of beams and plates in the bottom story. Now everything is okay. Now even you can go to the home button and you can go to the render view by simply clicking it here and going to the rendered view. So as you can see here, this is what the building got created. Okay, as you can see here, there is the top portion, it does not got created up to the 3 meter. The reason behind this is because this is a demo version, and in the demo version that the height which up to which you can create is limited. So here, because of that, this error occurred. So what you need to do is you need to go to again to the template, then again to the 3D truss. As you have set here everything, go to the y-axis and instead of 10 do here as 9. Now as you can see here, the 9 members are present here. Even you can go to the rendered view, as you can see here. But in spite of that, the error occurred here. As you can see here, the error is present here. Okay, so let me do one thing. Let me edit in the same option. Okay, so what I will do is I will go to the modify, I will delete. Let me delete it first. See, as I have deleted everything, so it's okay. Now what I will do is I will again go to the home button, I will apply the boundary conditions. Now I will apply the pinned load to everywhere. Let me do one thing. Let me select. Let me go to the XY view. After going to the XY view, let me select. Remember not to select the beam columns, only select the nodes. After selecting the nodes, apply to the selected. Now let me go to the isometric view. As you can see here, after that the nodes are created in the support is or support or the boundary conditions are created at all the nodes. So hope it's clear to all of you now how I have created the nodes. So everything is created now. After that, what you need to do is, so as you can see here, here the node is present, but it is showing in a 80% ratio. Just right click it. After right clicking it, go to the model view settings. After going to the model view settings, you can go to the members, increase it to 100%, plates increase it to 100%, wall panels not created. So even you can click on apply to 100%. So apply it. Now as you can see here, now the building looks completed. So as you can see here, now everything is completed. Now after that, what you need to do is as I have created the frame here, now you need to click in the home button. After clicking in this home button, what you need to do is you need to set the wall panels. For that, what I will do is I will click in this wall panels and I will rotate it by using shift and middle mouse button. Now I will create the wall panels from here to here. One wall panel created, but remember this again press Ctrl Z. The reason is because I have clicked on the wall panels, but those wall panels are created of concrete. Select it to masonry. Okay, material is concrete select general masonry. Then after that you can select edit all these properties. Okay, 1200 density, or similarly in the design rules also you can edit it, such as present here. As you can see here, the block thickness we can provide of 10 inch. Okay, we can even change the block thickness. What you can do is you can even go to the material set and click on concrete masonry. After clicking on concrete masonry, you can also edit it. Suppose such as here in the concrete masonry there will be the presence of concrete blocks, so I will be not using the concrete blocks, I will be using the masonry blocks. So let me select to the clay masonry, then let me edit it. Here also the same thing, so it's better to change to the general masonry, typical seismic rules, none. Now I will create from one by one, from here to here, from here to here. So this is how I am creating it. Okay, let me go to the home, let me show the wireframe view. After that I will let me create it one by one very easily by going to the wireframe view. So this is how I have created the wall panels. So hope it's clear to all of you. Now let me go to the rendered view and check it. See, as you can see here in the rendered view. Okay, so hope it's clear to all of you. So after that what you will do is you will go to the modify. After going to the modify, select all the wall panels. You need to select all the wall panels by clicking one by one. Go to the wireframe view, go to the wireframe view. After going to the wireframe view, you need to select all the panels one by one. Okay, after selecting all the panels, as you can see here, I have selected all the panels. I have selected all the panels. Or what you can do is you can go to this home button and select by property. You can click on select by property, select by properties. Now what I will do is I will select all the wall panels which are parallel to the wall panels which are parallel to, let me select here all the wall panels which are parallel to action first. Select action Z, So select all. Now let me check here. Now all the wall panels is parallel to XY. Select. Let me check here. This got selected. These three panels is they got selected which are parallel to XY. Now again select parallel to XZ. Select. So now all my wall panels is they got selected. See, as you can see here, even my now middle wall got selected. So this is how you need to select all the wall panels. After selecting, close it. After that, go to home, click on global. After clicking on global, click in the keep tool active and keep as Y increment to 3 meter because our height is 3 meter. Now apply it. Created. Sorry, I have clicked on move. I need to click on copy. So what you will do is click it to 0, apply to selected. I will press Ctrl Z. I will press Ctrl Z. After clicking Ctrl Z, what I will do is I will click on copy. I will keep this one, X increment 3, then apply to the selected. Now it will get copied above 3, then 6, then 9, then 12, then 15, then 18, then 21. So this is how we have copied the walls. Now click it here or press the escape button. Now let me go to the home and go to the rendered view. So this is how we have created the wall panels. After creating the wall panels and the supports are also present here. Now what I will do is we will go to the home button, go to the basic load cases. Here dead load, write the name of all the loads. Dead load, I will apply dead load, I will apply live load, I will apply wind load, then I will apply earthquake load, gravity and dead load minus of 1, rest okay. Category also you can change it. Dead load is dead load, live load is live load, wind load is wind load, earthquake load is earthquake load. Okay, then there is also the requirement of the roof load. Though roof load already roof rive load, but the roof dead load it will be calculated under the dead load. So there is no requirement of roof dead load. So let me remove the roof load because it's not necessary to apply it. Okay, now close it. After closing it, let me close this one. After closing it, now I will go to the line load. Now I will apply the dead load. As you can see here, I have already edited and I have done the category to dead load. So everything is okay here. Now give the dead load magnitude of 10. So about the calculation part, I have already shown in my previous videos of Stat Pro. Just simply go to my Stat Pro playlist and check there how to do the calculations for dead load, live load, wind load and earthquake load. But here I will simply show you how to apply the load of different magnitudes. Such as here I am applying dead load of 10 magnitude. So applying the full length. Okay, now I will apply to the selected. For applying to the selected, select by property. Now let me click it here and select all the members. Uncheck it, go to the member, select all the members as parallel to x-axis, select it, then select all the members parallel to z-axis, select it. As you can see here, all members is done. Now they are got selected. Now simply click on apply to selected. So this is how my load got selected, applied. After the dead load I have applied, now let me go to the, I have applied dead load. Now go to the live load. I will apply now the live load. As you can see here, I have applied, I have clicked here live load. Okay, now I applied a live load of 8 kilonewton. Again I will apply the live load over the, I will apply the live load, but though the live load I will apply here, but I will apply here in the form of the roof. So click on home, go to the plate surface load. Okay, go to the plate surface load. After clicking on the plate surface load, I will select the, I will select on the plate load. But actually instead of giving the plate load, because plate load is necessary for the, actually plate load is necessary in the case of the water tanks design. So here I will keep it as area load, and for the area load I will select it, go to home, select on area load. After selecting on area load, so after that I will apply the area load. As you can see here, the area load I will apply in the y direction, select as the live load, uniform load direction in the two-way, magnitude of minus of 10, exclude the braces. Okay, braces I have not applied here. Now what I will do is I will apply over the, minus 10. Okay, so let me click the area load. Let me select here all the plates parallel to, after that what I need to do is I need to apply the area load. As you can see here, area load is there, plate surface is there. So in the plates I will be applying the plate load, not the area load. So click on the plate load, click on the plate load. After that I will apply the live load, click on the direction, global y, magnitude of minus of 10. I have selected already all the, select by proper plates XY. I have already selected XY, unselect it. Now clear all. Let me do one thing, clear it everything, clear everything. Now go to home, go to plate, -2. Now click on select. After clicking on select, click the slab parallel to X, Z, all, select all. All the plates which are parallel to X and Z. all got selected. As you can see here, all got selected. Now I will click on apply to the selected. As you can see here, now I have applied the roof load as well in all the floors. After that, I have applied the dead load, I have applied the live load. Now I will apply the wind load. And for applying the wind load, what I will do is I will click in the wall surface. As you can see here, I will click in the wall surface for the wind load. So I will click in the wall surface. After clicking in the wall surface, I will apply now the wind load. The wind load must be applied in the positive X and positive Z and negative X and negative Z. Wind load must be applied. So let me do one thing. Let me apply the wind load. Now I will apply the wind load. After clicking the wall surface load, the direction which I will apply is positive Z. As you can see in this coordinate, this one is positive Z. Now let me apply the wind load of minus of 3. Suppose I will apply the wind load of minus of 3 in the entire wall. It's okay. Now I will apply, click to apply, or I will first select it. Let me select it all by using the control button. Now click to apply to the selected. So this is how, as you can see here, now I have applied the this panel not got selected. As you can see here all panel got selected. Here some of the panel doesn't got selected. Here this two panel and this one panel doesn't got selected. So I will select now again this one and this one and this one, apply to the selected, and let me select here. Yeah, now all my panels has got selected. In the similar manner, let me do one thing. Let me write as, let me again provide the wind load, earthquake load also in the similar manner, in the earthquake load also. Earthquake load also of, suppose I will provide of minus of 5. Entire wall earthquake load applied to the selected, earthquake load applied. Now in the Z axis, that is positive Z plus 5 earthquake load. Now I will apply on this wall. As you can see here also some of the member doesn't got selected. Here all the members says they got selected. Here 2 members doesn't got selected. What I will do is I will apply this one wall doesn't got selected, and let me apply it here first. Let me check here. Yeah, okay, this one let it selected. Now all members got selected. Now I will apply in this walls of plus 5. Apply to the selected. I have applied here plus 5. In the similar manner, I will apply the wind load of plus 3 to the apply to the selected. Apply to the selected. I have applied here because I have already selected. So I have applied in the Z direction. Now I need to apply it in the Y direction. So let me apply in the Y direction. No, sorry, in the X direction. What I will do is here I will write as X direction wind load. So as you can see here, this is the x direction here. Let me apply wind load of minus of 3 and x wall. Apply in the x direction, applied. So as you can see here, all the loads are applied. Now I will apply the wind load, earthquake load of minus of 5. Applied. Now I will apply in this wall of earthquake load of plus 5. Everywhere it is applied. Then earthquake load will be, so wind load of 3. Apply to the selected. Now applied. So this is how I have applied the wind load, earthquake load in both plus x direction and minus x direction, and wind load, earthquake load we need to apply in the 4 direction, plus x minus x plus z minus z. Similarly wind load also in plus x minus x plus z minus z. So this is how in this 4 direction you need to apply both the wind load as well as earthquake load. Live load I have applied, dead load I have applied. So everything is now being applied. Now let me go to the home. After going to the home, I need to click it. Let me go to the modify. After going to the modify, you need to click in this merge model, because what happens if there is any kind of node where merging is present, it will merge it, or if any error is there, it will merge all. So click on merge model, merge inactive, merge crossing members, trim extend crossing walls, apply all. So it is merging all the models. See, as you can see here, duplicate member found and merged. 189 duplicate members were found, so they were all merged. Okay, duplicate plates found, they were all merged. So this is what it is very necessary. Okay, so after that what you need to do is, so model merge is done. After that you have to click in the home button, then you have to click in this basic load combinations. Before load combinations, let me go to the basic loads, and you need to check here all are being applied or not. Yes, everything is being applied. Now go to the load combinations, click on load combination generator, click on load combination generator, wind gravity loads, rain load. I can also even include the rain load, roof live load, snow load, if this model is being created in the areas where snow is present, I can also even check this button. So let me click on this loads, generate it. After that I will go to the wind load, and I will click on wind load X and Z, generate roof wind load. Okay, semi diaphragm not required, generate it. After that go to the seismic load in Z and X. After that bracings not required, generate it. So this is how I have created the load combinations for wind load, seismic loads, and other dead load and live load. Now I need to click on solve batch plus envelope. So now the analysis as well as design process is its calculation part is going on. It's solving the process. Okay, you need to check the boundary condition. The model is currently unstable. Okay, let me check the boundary condition. Okay, now close it and let me go to the boundary condition and check for the boundaries, because there is no boundary condition present here, though I have applied, but somehow it got removed. So what you need to do is you need to go to the home button, go to the boundary condition and apply, click to apply. What you will do is remove the load first, then go to, before applying, go to the rendered view, wireframe view. After going to the wireframe view, click in this boundary conditions. After that, as you can see here, sorry, again go to the boundary condition. After going to the boundary, click to apply individual boundary conditions. I need to apply it. So let me click to the boundary condition, apply to click. So I need to apply it to all. I need to apply to all the boundary conditions. And what I will do is, after applying, check for the combination. If there is any error or what present. So the overall calculation is going on. Just wait for a minute. So hope it's clear to all of you how to apply the wind load, earthquake load, and how to do the calculation part. Just wait for a minute till the process got over. So as you can see here, now my duplicate nodes of the same coordinate detected and results may be invalid. Please perform a model merge. Okay, I'll perform the model merge once again. That's not an issue. So as you can see here, these are all my envelopes. So this is how we can do the calculation parts. Similarly, we can go similarly after that, what we need to do is you need to as I have showed you the section set. So what I will do is here first I will go to the section set and I will show here. See, there are various section sets present here, such as I will go to the concrete. These are my various section set: Bmax, Bmy and column. Bmax, Bmy and column. Actually I retain each name as Y is okay, but beam I should write its name as Z. So everything is okay here. After that I need to go to the code check. After going to the code check, go to the column and I need to check if any kind of member fails. Yeah, as you can see here, these members, select it, select the member and right click it, and after that show is sort by absolute maximum to minimum. These are all my values, they got failed. So what I will do is I will click on the suggested design. This member says they got suggested, resolve with the suggested walls. Okay, so it will automatically design the member based on its requirement. So this process is known as the optimization technique, which is actually used in the Risa 3D software. By the help of this optimization technique, it will automatically optimize the requirement based on the economical value as well as safety point of view. So it will make both economical as well as safer. Just wait for a minute till the process gets over. uh, I need to again resolve with the, let me check for again the code check. So still some of the members they are failing its results. So again go to the suggested, again let me go to the suggested design, click on the suggested design, then again click in this members as, resolve it. Still two of my, now my beam in the x directions are not safer, beam in the z direction are safer, now column in the y direction are not safer, again resolve. So in this way you have to click resolve with the suggested shape and walls 4 to 5 times. After that the building will automatically get safer. After the building gets safer, after that you have to simply check for the design, such as I will apply the loads here, and I can even simply go to this button and I can show you the axial load or shear, or even you can simply go to this home button. After going to this home button, these are my various values, quick view it's present here, so you can check from here, such as this one is the rendered view I have shown you, color frame view, this one is the color frame view, as you can see here. Okay, so after that columns are shown in red color, beams are shown in yellow green color, and in the y direction the beams are shown in z direction it is shown in green color, and in y direction it is shown in blue color. These are blue color and these are green color. So these are, this one is the, and whereas these all plates wall plates are general masonry panel materials is. After that click it here, wall panels. So these are now showing the shear values. Okay, shear in the x and shear in the x. Okay, they are showing the shear value in wall panels as well as in the plates. After that go to this point again and click on here, show the deflected shape. So this one is my deflected shape. Okay, after that you can even go to the material takeoff in order to check for how much amount of material is required. So this one is the material takeoff, that is total plates 68970 kg, M20 concrete, this total this much concrete kg, total this much masonry, and length also given. So this one will give you the full calculation part of how much material is required. Actually this is a part of the estimation, but it will give you here all the values. Even you can check for the seismic detailing for the beams, braces. So even you can go to the advanced results, you can go to the results, you can check for the contour diagram. Just wait. See, this one is my contour diagram says. So in this manner you can check each and every value. Even you can go to the envelope and you can check for the like suggested members. These are my two suggested numbers, this needs to be get corrected. So this is how I can do the analysis and design of the full building. Let me go to this portion and check for the uh, symbols, shear force diagram, bending moment in the z direction. These are my bending moments in the z direction. So this is how we can check each and every value. Even you can click in this detailed report to find out the report. So hope it's clear to all of you how to do the calculation part in Risa 3D. So if there is any kind of doubt, you can ask me in the comment section. I'll try to answer your doubt. So thanks for watching my video. Have a good day. Take care. Bye bye.